Hello, my good students. Today we have a challenge problem. Do you feel like you're prepared for the big challenge? So, this is the summation of alternating cubes. I have a video with summation of alternating squares. Maybe you want to watch that video first so to get some ideas, some inspiration. But today we're going to do this hard one, the cubes. And what do I mean by alternating? So this minus 1 to the power k, when k is an even number, that's a positive one. So it doesn't change anything. But when k is a odd integer number, 1, 3, 5, 7, up to 19, this is a negative. So this summation is alternating cubes, means minus 1 cubed, which is minus 1, then 2 cubed, positive, becomes 8. Then the 3 becomes with a minus. 3 cubed is 27. The 4 to the cubed is 4 times 4, 16 times 4, 64. And I have a positive, so positive 64. Then minus to the power 5 minus 5 cubed is 125, etc. all the way up to 20. Okay? So the odd numbers are negative of the odd number cubed. And the even numbers have a positive sign before them. And always we cubed everything. Okay? So this very complicated problem. And you know, you would spend a lot of time doing this by hand or put in the calculator. So yeah, there's a nice, beautiful trick. Mostly it practices your algebra and your reasoning. It's very interesting. To solve this, I will do some mathematics. Mathematics, huh? And I will use these 3 friends of mine, these 3 formulas, Formula A, Formula B, and Formula C. Formula A says that if I add up the numbers 1 plus 2 plus 3 plus 4 up to a certain number n, positive integer number n, that's the formula that I get. So those are the triangle numbers, numbers of this shape here. Okay, n plus 1 over 2. Formula B tells me that if I add up the squares of the numbers, 1 square plus 2 square plus 3 square plus 4 square, always sum of the squares all the way up to n, I'm going to get n plus 1, 2n plus 1 over 6. Okay, this holds for every capital N integer, positive integer number. Finally, Formula C helps us to decompose the difference of 2 cubes, x cubed minus y cubed. You can factorize that. That's easy to check. You could, for instance, multiply this times this, then this times that, then this times that. Minus y times this, minus y times that, minus y times that. You cancel everything. What you're going to have in the end is just x cubed minus y cubed. So this holds for every real numbers x and y. Okay? That's always the case. So we're going to use these 3 formulas to solve our problem. Come with me. Now the solution. Now we have our basic elements. We have our problem. We can attack the problem. Let's attack. So I'm going to write 2 cubed here, the minus 1 cubed here, then the negative 3 cubed is here, the 4 cubed is here. So I switch the order of these 2. I switch the order of these 2. I always switch the order all the way. Okay? Now for each parenthesis, I am going to apply C, formula C here. Okay? The difference of 2 cubes, I'm going to use this formula here many times, 10 times. So difference of 2 cubes is x minus y, x squared plus x times y plus y squared. Okay? So 2 is the x, y is 1 in this case. So this bit here is this bit here. Okay? Now, 4 cubed minus 3 cubed. X is 4, y is 3. X cubed minus y cubed equals x minus y, multiplying by x squared plus xy plus y squared. So this bit here is this term here. And I do this factorization many, many times until finally I get all the way to this, which is going to be this. So here x is 20, y is 19, x cubed minus y cubed is x minus y, multiplying x squared plus xy plus y squared. Okay? Now, how much is 2 minus 1? It's 1. And if I multiply 1 times anything, this can disappear. Here, the same thing. 4 minus 3 is 1. 1 times anything is just the rest. We can cancel all these factors here. Okay? What do we have left? Well, we have the 1 square, we have the 2 square left, we have the 3 square, we have the 4 square. We have the squares of the numbers from 1 to 20. And that's what I wrote here. The squares of all the numbers from 1 to 20. The summation of the squares of all the numbers from 1 to 20. Okay? But we have more than that. We have these cross terms here. One times 2 plus 3 times 4 plus 5 times 6, etc., and so on up to 20 times 19. Okay? We have these terms where we multiply. So 2 times 1 plus 4 times 3, right? I have this term, then I have this term, all the way. Okay? Now this, we will do a magic. This is the double of something times the number just before this, the one, this number minus 1. Okay? So the double of something is 2k. 2k, k going from 1 to 10. So when k equals 1, this is 2, this number. When k equals 2, this is 4, I'm here. When k equals 3, this is 6, here, and so on and so forth. When k equals 10, 2 times 10 is 20, I'm here. So I multiply this number by this number minus 1. This number here is one less than this. 3 is 1 less than 4, 5 is 1 less than 6, 19 is 1 less than 20. Okay, so instead of 2k, I have 2k minus 1. And then I can multiply this times this and this times that. So 2k times 2k is 4k squared. The 4 I put outside already. 2k multiplying minus 1 is minus 2k, and the 2 I push outside. Okay? And now I can apply my formulas A and B that I had before. Okay? My formulas A and B can be applied here. So for this term here, I'm adding squares all the way up to 20. So this 20 here is going to be my n in this first part. So this is n. So this is n plus 1. This is 2n plus 1. So if n is 20, n plus 1 is 21. 2 times n is 40 plus 1, 41. And I have to divide by 6 because my formula says so. Now here, when I have this bit here, be careful, the n now is only 10. Okay, so I have the 4, I have to keep the 4 here, but now this n is 10. So it's n, 10, n plus 1, 11, 2n plus 1. 2 times 10, 20 plus 1, 21. Always over 6, because the formula says so. Minus 2, it's here. And the sum from 1 to 10 of the numbers, 1 plus 2 plus 3 plus 4, etc. until 10, is just n plus 1 over 2. I can cancel this, obviously. And here I have a 6 in the denominator, and I have a 21, so I divide by 3. This becomes a 7, this becomes a 2, but here this 20 becomes just 10, and that becomes just 1. So I have a 10, a 7, and a 41. It's here. A 10, a 7, and 41. For this term here, I can divide by 2 here. And I have a 3. The 21 and 3, this becomes a 7. So I have a factor of 2, 10, 11, and 7. 2, 10, 11, and 7. And here I just have a factor, a negative 10 times 11. Okay? I notice that in these first two terms here, I have 7 and 10. I have 41 here, plus 2 times 11, 22. So it's going to be 41 plus 22. 41 plus 22. And I have a common factor of 7 times 10. And I keep my third term negative here. So this is 63. Okay? 7 times 63 is 7 times 6, 42. 420 plus 21, 441 minus 11. And I have a factor of 10. If I subtract 11, I subtract 10, this becomes 431, subtract 1, 430 with an extra, so it's 430 with an extra 0. I get to my final answer. Okay? So this kind of calculation is very smart. Lots of simplifications in the end. We need to know these three formulas to do it, but once we do, it's a straightforward process. Okay? I hope you have enjoyed. It's a fun, tricky problem. Very hard if you put in an exam, but now that you know the formulas, you can solve it. Okay? Thank you very much. See you next time. Bye-bye.